Okay, so I ended up, if you picked up the packet from last class like you're supposed to, it's going to be more of practice and clarification of the notes as opposed to the actual notes. So after looking at what I gave you guys, I wasn't happy with it. So we will still use that packet, but you're going to need, so it says all you need is a pencil. You'll actually need some paper to write on and a pencil for this. So if you were good about picking up what I asked you to, good job. But we're going to use, we'll use those notes, but not yet. So we're going to work on learning 4 shortcuts to proving triangles congruent. When we talked last class, if you're going to prove 2 triangles congruent, you have to show that every corresponding side and every corresponding angle is congruent. Okay, that's what we had before. Well, now we're going to learn 4 shortcuts that we can use to prove triangles congruent. Basically, there is where we had written down everything before, there's actually a minimum amount of information, and it's actually more than 4 cases, but we're going to learn 4 today, 4 shortcuts for that. We're also going to talk about vertical angles theorem, okay, and how to use that, which we mentioned it briefly, reflexive property, which again briefly mentioned, to be able to help us add information to triangles to be able to show them congruent. Okay, so common ways to prove angles congruent. All right, so if I give you that angle C and angle F are right angles, then your conclusion is that C and F are congruent. And your reasoning for this is because, and this is from unit 1, by the way, is that all right angles are congruent. It's just a fact. It's what we know. All right angles are congruent. Okay, so we know that C is congruent to F because of that. All right, for example 2 here, we're talking about angle APB, so this angle right here, angle APB, and we're talking about angle EPK. Now, this one you're hopefully recognizing immediately. How in the world can I say these 2 angles are congruent? Well, we can say they're congruent on here because of the vertical angles theorem. This is oldie but a goodie. We've been using this since chapter 1, okay? Now, we briefly talked about this a long time ago. So we're talking about unit 1 stuff, okay? So a while ago. But this is how we're going to start applying it more. All right, so if I give you the segment AD, so here's my segment AD right here, I'm tracing it, bisects angle BAC, so here's angle BAC. What does that tell you if it bisects it? Well, it creates, and you can see it here on the picture, I'm going to draw a little farther out, it creates 2 congruent angles out of that. So we can say angle BAD is congruent to DAC, and the reason is because that's what a bisector does. That's definition of bisect. That's what it does, bisect. When I say I have a bisector, it's cutting it in half. Okay, so those angles are congruent because that's the definition of a bisector. All right, or definition of bisect. All right, so for part 4 here, if I told you that B was 25 degrees and A was 25 degrees, okay, then we know the measure of angle B is equal to the measure of angle A. And your reasoning for this would be your transitive property, right? I mean, yeah, we've used transitive property a lot. Now, we haven't used this theorem as much to go from here to here, but this is definition of congruent angles or definition of congruence. Okay? We're not as focused on using definition of congruence now because we've kind of transitioned from doing very procedural official proofs to being more free form and open proofs, but that's what we're doing from there to there. More common ways to prove angles congruent. Again, going back to what we talked about in unit 2. Hey, look, I have parallel lines cut by a transversal. Okay, so again, we're saying, well, in this case, it's segments, but I have AB and I have CD, and then I'm saying that they're parallel, which is the triangle you see here and here. They also have a tick mark, which shows they're congruent too. But anyway, so how can we say that angle 1 is congruent to angle 2? Well, don't forget everything you know, okay? Don't forget everything you know. The situation we have is this right here. Here's angle 1 and here's angle 2. And these lines are parallel here and here, or segments are parallel. Well, hopefully you're recognizing that these are alternate interior angles. So alternate interior angles will be congruent. On example 6 here, if I tell you again that the segment XW and YZ are parallel to each other, okay, and then now we're looking here at angle 1 and angle 2 here, okay, again, if I were to redraw this picture and got rid of all the extras, okay, here's angle 2 and here's angle 1. Well, again, if these two lines are parallel, how can I say that 1 and 2 are congruent? Well, that's because they're corresponding angles. So again, we need to get used to using our parallel lines in our shapes. Okay, now we're going to go ahead and say, okay, I have these tick marks here on QR and RS and a double on SP and PQ, and that's all great and everything, but that doesn't really help you with PR. But over here, it's saying PR is congruent to PR. Well, the reason why you can say that, and again, this is something that we used a little bit last section, but we used it in chapter 1 too, is this is a reflexive property. If two triangles share a side like this, you can say it's congruent. You can put a triple tick mark there, and the reason is reflexive. The reflexive property. Okay. On number 8 here, if W is the midpoint of QS, so W is the middle of the segment QS here, okay, well then you know that QW, this segment, is congruent to WS, and I know there's a triple tick mark there, but we know that's a fact because that's what a midpoint does. It's the definition of midpoint. Okay, a midpoint's going to be in the middle. It's going to cut that segment into 2 equal pieces. So again, we know that JK is 15 and PQ is 15. So how can I say they're equal? I mean, we've seen this already. That's transitive property. So again, how can I go from a segment being equal to being congruent there? Well, this is definition of congruence, which we would have called it docs, but I'm okay with you saying doc. Again, this going from here to here, the given to here, that's more important to me than going from saying they're equal to congruent. All right, so just be aware, yes, knowing doc, it's good to know, but we're not going to lean as heavy into that going forward. So if I told you that the segment CD bisects the segment AB, well, then how can we conclude here that AD is congruent to BD? Well, that's exactly what a bisector does. Whoops. It's definition of bisector, definition of a bisector. Okay, that's what they do. They're going to cut it in half. So again, I briefly mentioned this from last class. If we're going to prove two triangles congruent, we need to know almost every single piece being marked, or to be able to reason it out using reflexive property or vertical angles theorem, or remember third angle congruence theorem, which says if two angles in a triangle congruent, the third one has to be. Okay, we talked about that a little bit too. So on here, again, this is kind of where we're at now. Like you have to have like everything marked. And today we're going to learn some shortcuts to this. Again, why do we know these two are congruent? Because every corresponding piece is marked congruent. Okay, so on here, what if we only knew that two angles and all sides are? So what's nice is that we do have all corresponding sides marked. We got a single, double, triple in each triangle for tick marks. That's great. The triangles aren't touching, so we can't try to use vertical angles theorem. We can't use reflexive property, anything like that. But do we have enough information to prove these congruent? And the answer is yes, we do. Now, the reason we do have enough information on here is because, remember, third angle congruence theorem, if I have angle Y congruent to angle M, and I also have angle X congruent to angle L, and we're talking about triangles here, then the third angle has to be congruent. So that means that N has to be congruent to Z. So I put a pretty sloppy triple mark on each of them. So now do I have every corresponding side and every corresponding angle marked congruent? Yes, you could write a congruent statement for this. So that was a lot of review and a lot of practice. Again, we talked about some theorems we haven't talked about since, the 4th week of school. So it was some old stuff on there. Okay, so now we're actually into official notes. All right, so we're going to talk about two shortcuts, side, 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 and side, angle, side. So hopefully it kind of makes sense when I'm saying side, 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 and side, angle, side, that's like the minimum information we're talking about. We're talking about all the corresponding sides marked congruent, and we're talking about two sides and an angle that's in between them. All right, so let's just look here. What is an angle what angle is included between segment ED, so ED is right here, and EF? So what angle is included between them? Well, that would be, in this case, angle E. Okay. So on here, which sides include angle G? So if I were to trace angle G, and maybe I will use like a blue. So here's angle G. So which sides make angle G? Well, I hope that it's clear to you that that would be the side DG and the side GF. Notice I'm not marking them congruent or anything. I'm just labeling them, right? So DG and GF. Okay, which sides include angle GDF? So using, I don't know, green. So angle GDF is right here. Okay, so which side, and again, notice how we couldn't just say angle D because there's a bunch of angles there. Okay, so which sides include angle GDF? Well, that would be, again, the side GD and DF. All right, again, it's important you're understanding what we're talking about here. When I talk about two sides, those two sides in a triangle are going to make an angle. When I talk about an angle, it takes two sides to make it. Okay, what is the non-included side for angle E? So we're going to talk about angle E on here. Again, angle E is up here. I'm going to trace it in blue. So I'm going to go over top of that red. So what is the non-included side? Well, that would be the side DF, right? That's the non-included side for that. Again, notice how I'm using correct notation. It'd be nice if that looked like a D. Okay, now, what are the two non-included angles for ED and DF? So ED, segment ED, and DF. So that's this middle right here and this left side here. So what are the two non-included angles? So we have one angle that's between them. That's right here. So we're talking about the other two angles. So that's angle E. And then I can't just call it angle F. All right, so that would be angle E. And then that would be angle EFD. And again, I can't just call it angle F because there's multiple angles at F. Okay, so that was a lot of talk about included angles, included sides. The reason why we're doing that is so that we can get in and specifically talk about an angle and you know what I'm talking about here, or a side and you know what I'm talking about. So on here, again, we have a shortcut, and that is our side congruence. And in fact, when we're going to write this on our paper, I want to write it as side congruence, like that. All right, so this is going to be our abbreviation for it, but it's our side postulate. And what it says is this, and I'm just reading it right off your paper. If the three sides of one triangle are congruent to the three sides of another, then the two triangles are congruent. So you're going to notice here that with my two triangles here, I have no angles marked. There's no angles marked. Well, I don't need them to prove they're congruent. Okay, just their sides. All right, and so again, remember, writing your congruence statement, it's all about the start. If they go ABC, so it goes single to double, then it better match that. So DEF, it goes single to double, and I'm talking about the tick marks. Okay, the order has to match. Now, looking at our picture here on the right, you're going to notice that you're going to look here and say, well, Mr. Borklin, that doesn't really help us here, because all I have here is a single and a double marked, right? We got a single mark on PY and YN, and we have a double here. We have a double. They're so close together, it's hard to see that it's a double. We have a double here on NQ and QP. All right, and you're going to say, well, okay, that's great, but what about, you just talked about having three sides marked. Well, they actually share this side, YQ. And so you can actually say that YQ is congruent to YQ by the reflexive property. All right, so looking at our three examples here. State if the two triangles are congruent. If they are, state how you know. So number one, again, we really only know side. We're going to learn the other three here in a little bit. But this is yes, because of side congruence. Okay, so again, we have a single, we have a double, we have a triple. For number two, what's you got to be careful with is I know our example only had 2 marked, but the picture actually had them sharing a side. This number 2 doesn't have this side being shared. So this is a big fat no because we don't have enough information here. Okay. On here, we have a single, double, and a triple on 4. So it's yes, a side, side, side congruence. And then number 6, again, you can use reflexive property to put a triple mark there. So it's yes by side, side, side congruence. It's kind of sloppy. This is where understanding the included angle is really important. A lot of times students will have a picture marked and it won't be the included angle that's marked congruent, and you're going to think it is. So you got to be really careful with that. All right, when we're talking about included angle, it's the angle that's right between the 2 sides that are marked. Okay, now for this one, this is side angle side postulate. So we're going to say SAS congruence. Okay, so now we know side, 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 and now we know side angle side. Okay, so I'm going to just read this to you. If 2 sides in the included angle, so the angle between them, of one triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. Now, again, you're going to look over here, and however you start is how it has to end. So notice, once again, it was nice when you have your sides marked. You got a single and then a double. So let's backtrack that for a second. I'm getting too far ahead of myself. We have triangle ABC. So ABC goes single to no mark. So when you finish, it's got to go single mark to no mark. This is how I do this. Now, if you have your own way to make sure your congruent statement is right, you can. Again, obviously, I gave this to you, so hopefully I'm not going to make a mistake. But again, if you're writing your own congruent statement, which you will, if you had gone, triangle ACB, okay, you could start it any way you want, but you got to match it when you end. So if I go ACB, well, that goes double to no mark. So you would go DFE. Okay. Now, looking at this example we have here, again, kind of giving you a little bit of hint what we're thinking about here. But I only have 2 sides marked. I don't have the 3rd side marked. I don't have any angles marked. But what you can mark here is vertical angles. So we know that the angle there at C, now again, you wouldn't call it angle C, but those 2 angles there, okay, are congruent. So you could say that angle ACB is congruent to angle DCE. Okay, and that's by vertical angles theorem. Okay, so state if the 2 triangles are congruent. If they are, state how you know. So again, we actually have 2 ways now. We have side, side, side congruence, and we have side, angle, side congruence. Remember, this angle's got to be between the sides. So on this first picture, they're both right triangles. That's great. Remember, all right angles are congruent. So this one is definitely a yes, and the reason is side angle, side congruence. This second one here, they share this side. I can put a single mark there. So again, it's another yes by side angle side congruence because it is the angle that's between those sides. For this third picture, again, I'm using a double because the single is already used. These are also congruent because of the same pattern. It's yes, and it's from side angle side congruence. And then this last one, you can use vertical angles theorem to mark those congruent there. And so our pattern here for this is, again, it's another yes by side angle side. Obviously, if we were giving you a test or something, I would not expect them all to be yes. But again, that also doesn't mean that I give you 10 questions and 9 of them are no's. Well, okay, so it's probably I give you 10 questions, maybe 2 are no, and the rest are your different theorems we're going to be learning. So go ahead and redraw these and try them on your own. State if the triangles are congruent. Remember, you do have those 2 methods. You have side, 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 and side angle side. Go ahead and pause the video. I'm going to go through these very quickly. Okay, so go ahead and pause, try these, and then check your answers here in a moment. Okay, so you can see that I've done these 6. Be really careful on 4 and 6. okay? Even though on 4 we did have vertical angles theorem, look at the pattern that's there, okay? We have a nice side angle side here on the right triangle, but this is actually side angle. Remember, it's got to be the included side, or sorry, included angle, and that means it's the angle between the two sides. And we have that on the right triangle, but we don't on the left triangle. So this is a big fat no. On number 6, it's the same thing. We have side, angle, side. Okay, that one checks out nice. But then we have angle, side, side. All right. So for 4 and 6, it's no's. The rest are yeses, or obviously the answers I gave you there. Again, being mindful of reflexive property when you can use it. Take a moment. Try these 6 questions, please. Okay, so I've done these. Again, I hope you're pausing the video and not just copying my work. You won't learn if you're just copying. You should really try it on your own. Please do notice number 9. There's just not enough information there. You have a side and angle. That's it. You don't have enough. Number 10, again, it's another situation where the patterns don't match. Okay, we have a side angle side on the bottom triangle, if you want to call that the bottom triangle here. And then on the top triangle, it's another angle side side. All right, so it's a no, the pattern doesn't match. Number 12, I like number 12. Now, because we have a right angle here on the left, and we know that these two angles that I put here, they're going to be supplementary. That means if one's 90 degrees, the other one is. So they're both right angles, and it's reflexive property, so this is side angle side. So just throwing together a lot of the stuff that we've learned. All right, so angle, side angle postulate. Again, this would be ASA congruent. So now we're talking about two angles and a side that's between them. Okay, that's between the two angles. It's almost another way to think about it. It's a side that's shared by the two angles. So I'll read this to you. If two angles and the included side, that's what this means by between them, of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. All right. Now again, noticing how it starts, the end has to match it. So the example we have here is we can use parallel lines and the reflexive property here on this example on the right. So they share that side there. Now again, if HF right here is parallel to GI, then that tells me that alternate interior angles are congruent. If FI is congruent to HG like this, then I also know that alternate interior angles. And it's really important you get the correct angles marked. One way you can do this is literally take your shape and pull it out. So if I would want to take this, and I don't have a lot of space here, but if I want to take, here's HG, right? So there's HG. There's that transversal right there. Try draw a little better. My bad, people. And then here is FI. If you would look here, if we're talking about HG and FI being parallel to each other, then the alternate interior angles are right here and here. So it's making sure you're getting the correct ones marked. And I guess I should put a double because that's what I did in the picture, right? Put a double on there. All right. And the same thing with the left and right sides. All right. So we were able to say, that angle 1 is congruent to angle 3, and then angle 4 is congruent to angle 2. And the reason is because they're parallel lines, so it's actually, alternate interior congruent for both of these. So if we were writing a free-form proof, we could add something like that to it. Okay. Now, write the congruent statement. Can the triangles be congruent by angle, side, angle? Again, and I do want us writing as angle, side, angle, congruent symbol like that. All right. So looking here, sorry. Write the congruent state for which two? Sorry about that. For which two can? So I have 3 triangles here. We can clearly see, well, maybe not clear. This is a little small here. But this one is, the pattern is angle, there's an angle, and then a side. Okay, so on here, this one doesn't even fit our pattern that we're talking about. We're only talking about angle, side, angle. So which two can be? These two, here and here. Okay, and this is really hard for me to see, so it probably is for you. I'm going to assume that the single arc mark is on U and E. I'm going to assume that, which means I'm going to assume that the double is on the other two there. If I'm wrong, it's whatever. So So again, it's all about how you start it. And when I give you a test or quiz, I'm going to usually start them for you. And the reason I'll do that is because it limits the number of answers you can give me. So let's go USV. So if I say triangle USV, I want to know what triangle that's congruent to. And so then you would go ahead and you would finish this. So why don't you pause the video and take a moment to actually do that? So hopefully you put ENO, ENO. If I go U, that's a single arc mark, S is no arc mark, and V is double. If I go, so I want to go single, none, double. So E is single, N is none, and Q or O, I don't know. I can't tell if it's a Q or O. So I'll just say it's an O. All right, so there's that. So looking at the second one here, again, our pattern is angle, side, angle. Well, again, this middle one here, it's actually the pattern of angle, angle, side. All right, again, when we go angle, side, angle, it's got to be the side that's between the two angles, not outside of it. So it's got to be the first and last here. This is a little clearer. You can see the double on H and A. So again, they're congruent by, angle, side, angle, congruence. Okay, congruence. All right, so if I start it again, I will go H, G, O, and then I want you, that's a great congruent symbol. I want you to take a moment to actually finish it for me. So pause the video and do that. So if I start with H, H is the double, G is the single, O is none. So I want to start with A is the double, C is the single, T is none. So, it's ACT, or ACT, sorry. What am I saying? Anyway, so we have HGO and we have ACT. All right, our last one is angle, angle, side. So angle, angle, side congruence. Okay, now again, it's really important you understand the difference between angle, side, angle, and angle, angle, side. So two angles and a non-included side of one triangle congruent to two angles and the corresponding non-included side of another triangle. So again, when I'm talking about two angles, so in my picture here, if we're looking at this triangle here, if I'm talking about angle A and angle B, the included side is literally the side that's between them. So this side here, okay, that's the included side. The non-included side are the other two. So it's really important you're able to get that down. A lot of students struggle with this, and part of it is because, honestly, sometimes they're only halfway paying attention. Okay, so anyway, again, however you start, make sure how you end it matches. Okay, now we're talking about a non-included side. That's why the S is after the two A's when we write it here. So looking at my picture here again, hopefully you're like, oh, reflexive property. I mean it needs to become such a habit that when I have a picture like this, it's like boom, reflexive, nailed it. Okay, again, that'll be worth points on a quiz or test, being able to just mark that, simple mark there. We have angle A congruent in both. Again, naming it angle A is a bad way to say it because there's more than one angle there. But we have two right angles, which means they are congruent. Okay, and I'm not going to draw arc mark, but we know those two angles are congruent there. Okay, so in my picture, again, we have the pattern angle, angle, side congruence. We do. So if I were to start the congruence statement, and you need to be practicing this, you really do, because this is one of the things students struggle on the most, is being able to get this correct. If I go, and I'm going to be nice to you, if I go DAC, that triangle is congruent to triangle blank, and I said, hey, what's the congruence statement? Can you finish it? Well, again, I went right angle to the double mark, and then to no mark over here at C. So I need to go right angle, which is B, to the double mark, which is at A, all the way over to C. So if I go DAC, you would go BAC. All right. Now, are the following pairs congruent? If so, state theorem possible use to prove. All right. So again, right now we have 4 ways. So we do need to be thinking that way. Okay. Number 1, this is not the one we just talked about. It is not angle, angle, side, but it is angle, side, angle congruence. So yes, it is. I know I didn't write yes, but I mean, it's kind of redundant. Number 2, when I'm on here, I can add a right angle here because they're vertical angles. And so I have another angle, side, angle congruence. On number 3, reflexive property. Okay, so now it's another yes, and now we finally get our angle, angle, side congruence. On number 4, we have vertical angles. I got to use a double because my single's already used. And we have angle, angle, side congruence again. So the last 2, 3 and 4, were the new one we just talked about. I would like for you to write these down and see if you can do them. You're going to want to pause the video because I'm going to give you the answers here in a moment. Okay, so you're going to notice that angle side side, ASS, is not one of the reasons we talked about. You've got to recognize that pattern and realize that's not one of our shortcuts. It's not one of our shortcuts because literally you can't actually prove it with that information. You need more information than that. But also, I mean, it's a swear, so please don't write it down. Okay, so no, number 1 is no. 2 is pretty straightforward. 3, you got to be careful. We have reflexive property, that's nice. But if you notice here, again, the pattern we have for each of these, well, again, I have a single and then a double with the angle between, so that would be side, angle, side, right? That's possibly what it could be, right? But the other one is not. It's again, it's this angle here, and then it's a double mark and a single. So that's the pattern, you know, ASS again, right? And that's never a reason. So they obviously don't match, so it's a big fat no. All right. Number 4, reflexive property. So number 5, use vertical angles. Number 6, again, we went single, double, and then double tick mark. Single, double, and then double tick mark. The patterns match. It's angle, angle, side for 6. Sorry for such a long, this is a very long video, I'm sorry. Okay, so go ahead for these 6, write them down, try them out, see if you can get them. You're gonna wanna pause this because I'm gonna give you the answers here in like the next 3 seconds. Okay, so here are your answers. You can see that there aren't really any surprises here. We used reflexive property and vertical angles theorem a couple times on here. Again, I think what is going to give you trouble is recognizing when it's, you know, angle side angle, or so when it's this situation here, or when there isn't one on here like this, or when it's angle angle side. Okay, I think that's going to be one of the biggest issues with that. That and maybe recognizing when you have, you know, side angle side and not angle side side, which again is never a reason. Please don't write that. Again, that's a way to trigger Mr. Borklin, is use that when I tell you not to. Okay, so anyway, again, so just kind of check those out, see if you got them right or not. Okay, so what's nice, or what's a nice way to challenge students is to make them use a certain method. And so what it's going to require from you is drawing an accurate picture. So state the third congruence that must be given to prove that these 2 triangles are congruent using the indicated postulator theorem. So obviously you can see here, here, and here. So an accurate picture is important. And you need to do a new picture probably for each one, just because you're going to mark it. So using your own paper and me using the space that I have on here. So we know we have triangle A, B, C, and we're saying that's congruent to triangle X, Y, Z. So like this. So if I know that A is congruent to X, and I know that B is congruent to Y, which again, that's just the given. I'm just looking at number 4 here is all I'm doing. Okay, and we're going to use the method angle, angle, side. All I'm doing is missing a side. So you actually have 2 options for your answer here. Okay, you can either make it side BC and X, or sorry, BC and YZ, or you go the other way and make it AC and XC. I'm just going to leave it at what I did there. So if this was a test question, I'd have multiple answers I'd have to check. Okay, but what is the third piece of information we need? We need that the segment BC is congruent to the segment YZ. So I want you to go ahead and try to finish 5 and 6 using this. So draw a picture, mark what you have, finish by the method we want. So pause the video and try it. So I hope this is what you had before you started answering the question. I'm going to give the answer here right now. Okay, so we would have gone ahead with number 5, and we would have said B and Y being congruent, because we want to go angle, side, angle. So angle B and angle Y have to be congruent on that. Number 6, you'd have to go with angle A and angle X on here, because again, we're going to go with angle, angle, side. It was the only for both of these. So for number 4, you actually had some choices. You had 2 options. You could have gone with 2 different answers. With 5 and 6, you had to say the specific way they mentioned, or it wasn't going to fit what they wanted. All right, so for the next 3, all right, you're just going to go ahead. Is it possible to prove them congruent? If so, state the reason. So we've kind of already done this a bunch, but just go ahead and do it. Okay, so for number 7, you can do the reflexive property. The problem is you have the pattern angle, side, side, which again, it's not a reason, okay? Not one of our 4. All right, number 8 is yes, you use vertical angles theorem. It's angle, angle, side. Okay. And then number 9, even though it looks a little weird, you know that our angle here is a right angle there and there because of linear pair postulate. So you can say that that's a right angle there. And so then we have the pattern right angle, single arc, and then side. So right angle, single arc, and the side. So it's angle, angle, side for number 9 as well.